Highway Administration's Office of Safety and the Pedestrian and Bicycle Information Center. Today's webinar will focus on roadside landscaping, specifically street trees, and related safety impacts and trade-offs. Panelists for today's webinar include Dick Alvin, a safety engineer with the FHWA Resource Center's Safety and Design team, and John Mothner, a design standards engineer with the Florida Department of Transportation. My name is Dan Jeline, and I'm the program manager at the Pedestrian and Bicycle Information Center. I'll be facilitating today's webinar. The first presentation coming up is going to be from Dick Alvin. Dick, whenever you're ready, please go ahead and take control of the screen, and you can continue with your presentation.
Okay, yes, my name is Dick Alvin. I work with the Federal Highways Resource Center, and I'm on the Safety and Design team. And on the Safety and Design team, we have different people that handle different focus areas. Peter Unn is primarily involved with the pedestrian area, whereas I am more involved with the roadway departure crashes. And this webinar kind of came about between Peter and I discussing things that we were working on and realizing that we may in some cases be giving conflicting information. And we thought that this would be a good opportunity to have a discussion regarding trees and landscaping and the urban environment. So first off, before we start, I know that there's some things I'm going to be saying that many of you may not like so much, but I do like trees. I think that they're very beautiful, inspiring, and make people do things like write poems about them and things like that. Where I have a little bit more of an issue is when we start getting them close to the roadway, and there's that opportunity that some people may run off the road and hit a tree. And so the question here is to street tree or not to street tree, and that's what we'll talk a little bit about. And it's not necessarily whether or not you have trees or don't have trees. Sometimes it's in the positioning of them, where they're placed. So street trees, there's sites and research that's occurred that has looked at the benefits of street trees, and they've been attributed with increasing the amount that people will pay for services, lessening the stress of commuters, reducing aggressive driving, increasing job satisfaction, reducing stormwater runoff. Another one is calming of traffic, and that's kind of the surrogate that's been used to address pedestrian safety, is that if we can reduce speeds, the 85th percentile speeds or whatever it might be, that might make it safer for pedestrians. So that's kind of the surrogate that's been used for the pedestrian side of things. But in a lot of cases, the impact of hitting a fixed object like a tree has been somewhat minimized, and there may be some opinions that fixed objects aren't an issue in an urbanized area. Some might think that's because speeds are lower and so there's less impact forces and things like that. So I'm hoping to talk through a little bit more on that as well. One of the things I've seen quoted in a couple places now is this chart here, and the conclusion that came from it is that far less than 1% of all crashes involve a tree in an urban street. And I think that this is a little bit misleading. If you look at the, I can't argue with the calculation of the numbers, the urban tree accidents at 0.7%. But when you take any value, any number, and divide by 6.3 million, you're going to get a very low number. So I think that this is somewhat misleading. And I've seen this not only in the original research, but also quoted in subsequent researches, is that, it's the number of tree crashes is less than 1%, so maybe that's not as much of an issue. If we were to take another look at things that have a higher severity, such as pedestrian crashes, and I used a value of like 5,000 pedestrian crashes. I think the number is actually 4,700 or something that happened in 1 year. It's actually 0.08%. So I don't think we want to minimize the very high severity crashes, and trees are also in that boat. I am going to be talking about tree crashes, and those are part of what we call roadway departure crashes. And this just shows our current definition. It's going to probably change a little bit. But when we look at roadway departure crashes, those typically are more than half of all of the fatal crashes that happen in the country. Out of the about 30,000 fatal crashes that happen per year over the last few years, almost 16,000 of those were roadway departure crashes. And those include running off the road and hitting a fixed object, maybe rolling over, things like that. And when we look at the roadway departure crashes as part of an effort that we had to look at a strategic plan for roadway departure, we found that 3 crash types made up 75% of all of the roadway departure crashes. And those were overturn crashes, opposite direction crashes, and then trees and shrubs. And so to look at this, kind of the way I from a strategic standpoint is, if I go back a slide, is if we want to bring down the number of fatal crashes and high severity injury crashes, we have to do something with roadway departure. And if we're going to reduce roadway departure crashes, we need to do something with these 3 areas. And so trees is one of those. Now, something that you might find a little bit surprising is when we look at just the tree crashes, which makes up about 20% of all roadway departure crashes, about 10% of all fatal crashes, that when you look at it by rural and urban, it's about 2/3 rural, 1/3 urban. And that's how it was classified. But when you look at it based on speed, and that's the values in the middle there, posted speed of less than 45 miles an hour, 45 miles an hour or less, which is the AASHTO definition of a low-speed highway, 45 miles an hour or less, about half of all of the tree fatal crashes happened in that lower speed environment. So it might be surprising that it isn't just a high-speed rural issue. There are fatal crashes into fixed objects and trees that happen in the urban area. About 1/3 of all of them it would be classified urban area, and half of them happen in that speeds of less than 45 miles an hour. This is just a chart that came from the Insurance Institute for Highway Safety, and they used the FARS data, Fatal Analysis Reporting System data, and it's broken down by speed. And this is looking at different speed ranges, and you can see for the area 50 miles an hour and less is where they cut it. You see the numbers calculate up to a little bit over half of all of the fatal fixed object crashes happening in the lower speed, or the 45 to 50 miles an hour or less. When you get down to less than 35, the numbers drop off. So there might be things that might be more appropriate in where you have operating speeds and speed limits of 35 or less. But when you look at the area between 35 and 50, there's a lot of, almost 40% of all of the fatal fixed object crashes happened in that area. And this is just a video that's going to show kind of the impact. And these speeds, you're going to see 3 different crash tests. They're in kilometers per hour, so 50 kilometers per hour is equal to 30 miles per hour. 70 kilometers per hour is about 43, and 90 is about 55 miles per hour. And this was a test that was done to kind of simulate a tree. They brought a tree in and mounted it in a lab. But you can see how much penetration, even at 30 miles an hour, happens when a vehicle hits that. At 70 kilometers per hour, it's even more. And then at 90 kilometers per hour, the tree ends up in the driver's seat area. So that's why tree crashes tend to be a very severe type of a crash. They're narrow but rigid objects that almost cut into the vehicle like a knife. And that's a head-on hit, but a lot of our crashes aren't head-on, and when you slide into something and hit it on a door area, there's less cushioning for the occupant of the vehicle, and there's more potential for injury. So those might even be a worst case where you get the side impact type crashes. So that's what we know about statistics, the data on where crashes are, fatal tree crashes are, and why they're so severe. What we do here is that, well, we need trees. There's some thought that they provide a benefit for pedestrians. Some might say that they provide a barrier for pedestrians. If somebody does run off the road, they'd be hitting the tree rather than the pedestrian. And I don't know that I would count on the tree if that's what the concern was. Having a tree every 50 feet probably isn't going to provide a very good barrier. But what we're looking at really is a trade-off. what are we doing for pedestrians, and does that really provide a good barrier for pedestrians by adding that fixed object at the curb line. And one thing that we looked at a few years ago was we looked at, using the fatal analysis reporting system, which is the best data that we have as far as fatal crashes go. We looked at the urban arterials, minor arterials, and collectors, and we found that the number of cases where somebody ran off the road and hit a pedestrian on the roadside was about 48 pedestrians were killed in those situations, which is bad. We hate to see anybody killed, but the number of people that were killed from running into trees on those same roadways was about 400. And the trade-off is by adding trees, are we really going to reduce the 48 pedestrians? And I'm pretty sure that we're going to increase the 400 people that were killed from hitting the trees. So that is a trade-off that I think needs to be considered when you're thinking about installing new and where you place those trees. Other impacts from a pedestrian standpoint that I've seen that I think need to be considered through is how do they affect the visibility of things like signs that are there for pedestrians, such as the yield sign in this photo here, that might, when the trees get leaves on them, like you see in this picture here, it makes it very difficult for the motorist to see that sign or see the pedestrian that's standing at the crosswalk about to step out. So I think that there's an impact there from a visibility of the pedestrian standpoint that needs to be considered. This is a report that was done a few years ago, presented at TRB and published in the TRR that's listed there, that looked at the effect on lighting. The photo on the left is in a wintertime situation, so there's no leaves on the trees. The photo on the right side is in a winter time where there are leaves on the trees. And you can see the lighting is less effective because the trees filter out that lighting, and that also might have an impact on the pedestrians. This is maybe more of an extreme situation, but you see quite often where there are trees, especially between the curb and the sidewalk, that the roots, as they grow up, they tend to blow up the sidewalk and cause problems there. Again, this might be a little bit more of an extreme situation. A lot of times we see an inch or two where that might stick up, and that might cause tripping issues. Here's a couple cases where trees have been installed, and over time that they were getting hit, and so you can see there's wells there where there's no trees in them. And the one on the left-hand side, the city actually went to the effort of filling that in with asphalt to make sure that nothing grew up there anymore, which now it looks like it's just a obstacle or something that's in the sidewalk that might cause somebody to stumble here or there. So, the trees don't necessarily like being there. We know that they're going to get hit when they're in that type of a situation. The other thing that we've heard, and I think there was a paper on this presented at TRB this last year, was concern from bicyclists when you have objects that are right next to the curb area. And in this case, you have the branches that hang down and might cause an obstruction in the bike lane. The other part of it, from an ADA standpoint, is making sure that branches are more than 7 feet up so that people can walk through without hitting on those branches. So that's just something else that needs to be considered with the trees when they are getting close to the traveled way and the sidewalk area. But the thing that I want to get into, and this is where I probably have some people that aren't very happy with me at this point, but not all streets are the same. Both of the photos on the screen you would call an urban, according to AASHTO, would fit the low-speed definition of a low-speed urban highway or urban environment. But they're very much different. The photo on the left-hand side, which is more of a downtown core that has street parking, on-street parking and buildings and things like that, I'm less concerned about those, and I think that those tend to be lower speeds where we have signals every block or so, and it regulates traffic pretty well. On the other side, on the right-hand side, it's much more wide open, and more room is available for things like bike lanes and buffer strips, and usually the buildings are further back. We also might expect vehicles to be traveling faster, more in the 40 to 45 mile an hour speeds. And so I think that there is a different context between these two. I'm much more concerned about the photo on the right in regards to having fixed objects at the curb line than I am with the photo on the left. But just to talk a little bit about what AASHTO says. These are a few quotes that are in the AASHTO Green Book. There was a revision made in 2011 that included some more information that came out of some of the research that was being done and clarifications that were being made. And this is a quote, in the urban environment, right-of-way is often extremely limited, and in many cases it is not practical to establish a full-width clear zone using the guidance in the AASHTO Roadside Design Guide. And I have called myself a roadside safety nut, but I agree with this. I agree that in the urban environment, it may not be practical to establish that full-width clear zone that you might pull off of the table in the Roadside Design Guide. However, as we'll go through, I don't think that we just disregard it altogether. There is discussion in the Green Book about providing a lateral offset, and I think people have been confused about what that lateral offset is there for. That the lateral offset is generally about 1.5 feet to 2 feet from the face of the curb, and it says in the Green Book that that area should be clear of signs, utility poles, luminaires, even things that on breakaway supports. So it's not a fixed object necessarily, it's just anything that sticks up. And the idea of that is that we want to avoid people having a sight distance issue, or we want to make sure that people can open up their car door if they're parking, things along those lines. But it isn't really there to act as a clear zone. And I think some people have confused it with thinking maybe the curb provides some type of barrier that keeps people from running off the road. And here's a case where curb was actually put in to mitigate fixed objects, but the curb is going to be doing very little for you in that situation. It actually makes it worse because it lifts the vehicle up. Also in the Green Book, it talks about on curb facilities located in transition areas. And I'll tell you that transition areas was used because they didn't want to use the word suburban because it wasn't defined anywhere. So they used transition areas to mean the areas that weren't necessarily the downtown core, but they weren't a wide open rural area either. So they're transition areas between rural and urban. There may be an opportunity to provide greater lateral offset in the location of fixed objects. So what this is saying is that don't just limit yourself to the 1.5 to 2 feet. If you can provide more area, that might be appropriate. The facilities are generally characterized by higher operating speeds than your downtown core area. And a lot of times they'll have a buffer strip or things like that between the sidewalk, things along those lines. So that's just a general category of roadways. And so what it concludes with is where establishing a full-width clear zone in urban areas is not practical, consideration should be given to establishing a reduced clear zone or incorporating as many clear zone concepts as practical. So what it's trying to say is don't throw the idea of a clear roadside or more recovery distance out the window just because you're in an urban area. Some research that was done to look into this further and it ended up being published in the NCHRP Report 612. That report was also the basis for the revised Chapter 10 in the Roadside Design Guide, and I'm going to show you some figures that came out of that. They looked, that research team looked at corridors around the country, and they found, they looked at where their fixed objects were, they videotaped them, they looked at crash histories, and they found that over 80% of the crashes into fixed objects happen when the fixed objects are within 4 feet of the curb. And about over 90% happen when they were within 6 feet of the curb. And so using that information, this is the guidance that's in the Roadside Design Guide that says if you are going to have fixed objects or that you do need to plant trees and things like that, that you should try to be getting an enhanced lateral offset of at least 4 feet, preferably 6 feet in those areas. More around the outside of curves. On the inside of curves, sight distance is a consideration as well. They also identified specific locations where maybe you need to pay a little bit more attention, where they saw more crashes occurring. They found more crashes occurred at merge and taper areas, so they recommended in those areas that you have a wider buffer area, a wider enhanced lateral offset. On the far side of driveways, they found more crashes happen when there was a fixed object on the far side of driveways, so there's a figure that shows providing a little bit more distance in those areas. And then when you had buffer strips, there's different configurations that are out there. Here's a fairly wide buffer strip, same as here. What it shows is that if you have a buffer strip that's greater than 4 foot, to try to get at least 4 foot of offset to your fixed objects, such as trees. The one thing I'll note is that the figure label here is incorrect compared to they got those swapped in AASHTO, and they haven't issued an errata for that yet. But the figure label says less than 4 foot, whereas this one really applies to the greater than 4 foot. And this is the other one, though, is when you have a buffer strip that's less than 4 foot, that you might use some type of small shrubbery between the sidewalk and the curb, but your larger fixed object trees, if you're going to be putting them in, should be on the back side of the sidewalk. And this is just showing a picture that illustrates that, where you have shrubbery, things like that wouldn't be a fixed object, that helps to delineate the border between the sidewalk and the traveled way. I'm not crazy about the utility pole, but they do have the trees that are set back behind the sidewalk, and I think that's a pretty good installation. There are some cities that have wanted to do things, especially in medians, to put in plantings or statues or things like that. And here's a couple cases where they did use a barrier, low-profile barriers, made of concrete that basically provide a planter area that allowed for the planting of the trees. You will see crashes into the barrier, but we hope that those will be less severe than larger trees once they get bigger that isolate the load on the vehicle. Another tool that's out there that could be used to evaluate or assess the risk of different installations is the Highway Safety Manual. And in the Highway Safety Manual, there is a chapter on urban-suburban corridors, and there's a CMF. And a CMF is a crash modification factor that basically just gives a relative effect on the number of crashes that you can expect by doing different things. And in this case, it's looking at the crashes into fixed objects. And you've got a calculation there that's based on the offset, density, and proportion of fixed object crashes to total crashes. It looks more complex than it is, and I'll just run through a couple examples here. In the Highway Safety Manual, if you're looking at a 4-lane urban undivided street with trees at 2 foot offset from the curb line, use a fixed object offset factor for 2 foot, which is 0.232. It's a 4-lane undivided, so we'd expect about 3.7% of our crashes on that type of a facility being fixed object crashes. It's based on research that was done, and so those are just pulled off of a table, and then we go into our calculation. So we have a 4-lane undivided commercial curb street with trees on both sides at 50-foot spacing, and they're 2 foot from the edge of the traveled way. We use our fixed object factor that we pulled off the chart. We have our proportion of crashes, and then in between that we have our density, which is the 5280 divided by 70. Now, I said that it's 50-foot spacing, but with this CMF, what they looked at was everything within 70 foot being considered one object. So we divide by 70 there, which is a little less conservative, and it is on both sides of the roadway. So if we calculate that through, we come up with a value of 2.258. And what that means is, compared to having no fixed objects along a roadway, you can expect to see about 2.2 times the number of crashes than if you had the trees at the 2-foot would have 50-foot spacing. Now, if you were to move that to 5 foot, your fixed object factor changes, and you calculate a value of 1.7. So you'd see about 70% more crashes than having no fixed objects at all. And if you were able to move it out to 10 foot, which might be the same as back of sidewalk, you could expect to see about 50% more crashes in that type of a situation. So again, the Highway Safety Manual helps to assess the risk, and that might be as if you're looking at doing something, putting in fixed objects as trees, and you're looking at what the risk is there, that might help quantify that for you. So just a quick summary, and then I'm going to hand it over to John to talk about intersections. Crashes into trees are a significant contributor in fatal crashes, even what might be considered a low speed, which AASHTO defines as 45 miles an hour or less, urban environment. When you get down to the 30 miles an hour and below, there's less of the fatal crashes there, but there is still about 15% of fatal crashes that happen where the posted speed is at 30 miles an hour or less. The benefit of trees need to be balanced with other trade-offs like safety and crashes. The recent changes in AASHTO encourage greater lateral offsets to fixed objects, a minimum of 4 foot to 6 foot, and you can still have crashes when they're out at 10 foot, but the majority, 90% of them, were happening within 6 foot, and the risk of crashes does decrease as the objects are moved further from the traveled way. And so that's what I have. Dan, I don't know if you want to switch right over to John at this point.
Yeah, let's go ahead and continue on with John, and then what we'll do is circle back around for some questions at the end. While I'm switching screen control over to John, I do want to mention, everyone, we've gotten a few questions about the where the slides will be made available, and so I just wanted to reiterate that the slide presentations, the PDF version of these slides will be posted on our website, and each of you is going to receive an email after the webinar is over with a link to where you can find that information. So just wanted to let you know this will be available after the presentation. Just be on the lookout for that email. And again, just a reminder, if you're the only person who registered for the webinar and you've got others with you, be sure to just forward that email on to them so they have the information as well. So John, your screen is up and it looks good, so I'll go ahead and hand it over to you to continue the presentation.
All right, thank you, Dan. And Dick, that was a great presentation. I appreciate the time that you took to put into that. My name is John Mothner. I'm with the Florida Department of Transportation, and I've been with the department very close to 30 years, and it's getting close to retirement time, so this is kind of exciting for me to be able to do something like this and to report on sight distance at intersections. So today we're going to discuss Design Standard Index 546, sight distance at intersections. And I'll give you a brief introduction. What we're going to do is we'll look at the landscaping of highway medians at intersections. This was a research project that was conducted by the Center for Urban Transportation Research at the University of South Florida in Tampa. And we're going to cover the need for the research and the background. We're going to look at the research objectives and the methodology. And then we're going to take a look at some of the conclusions and recommendations. These research projects provide revised data for Design Standard Index 546, and the revised standard will be published on July 1st of 2014 for the January 2015 Design Standards e-booklet. Based on this research effort, I'll look at a little bit and discuss some of the need. Recent interest in road beautification initiatives as a way to help economic growth led to changes in landscaping policies in Florida. These changes reveal the need to evaluate whether the criteria for landscaping requirements in Index 546 remain valid for providing guidance on the installation of plants and trees within medians located near intersections. The background for this, Index 546 provides guidance on sizing and spacing requirements for plants and trees in medians located near intersections, and it serves as the department's policy on criteria for sight distance at intersections. To validate the intersection site distance criteria in Index 546, a research project was conducted by USF and the Office of Design, and that's entitled Landscaping of Highway Medians at Intersections. So let's go ahead and take a closer look. The research project was initiated by the Florida Department of Transportation, and again, we were looking at the validation of Index 546 and its criteria, and then also we're looking at proposed changes to Index 546, and those changes would be based on the median width, tree diameter, tree spacing, and vehicle speed. In order to evaluate the research and discuss some of the background, we need to take a look at the Context-Sensitive Solution Initiative. The Context-Sensitive Solution Initiative began back in November 2008, and this was a collaborative interdisciplinary approach, and we needed to develop a transportation facility that fits its physical settings, but also preserves the scenic, aesthetic, historic, and environmental resources, as well as maintaining the safety and mobility for pedestrians and motorists alike. According to the Federal Highway Administration, a context-sensitive solution is a collaborative interdisciplinary approach. This involves all stakeholders to develop a transportation facility that fits the physical fittings, and it also preserves the scenic environment, and it still does maintain safety and mobility. Context-sensitive solution is an approach that considers the total context within which a transportation improvement project can exist. The next thing we're going to look at is highway beautification and the bold landscaping policy. Many trees, $30 million a year for highway beautification. The highway beautification and bold landscaping policy was a statewide policy to promote economic growth, and it strived for ways to attract more businesses and visitors to Florida. In 2011, one of the department's policies which contribute to this goal is to implement bold roadside beautification projects. This policy incorporates planting trees at specially designated sites and includes the $30 million of funding per year for the highway beautification. In 2010, we delivered a roadway design bulletin 10-04, and it covered tree placement within an intersection median. It looked at the horizontal clearance requirements. It also discussed the no left turn present options, and also when a left turn is present, whether it's signalized or not. And then again, based on whether it's a low-speed facility, it had a 100-foot setback, and then for high-speed facilities, it incorporated a 200-foot setback. The bulletin did not change the requirements to provide adequate sight distance at intersections, and it still is important to maintain a clear sight window. Additional information on background. Before Roadway Design Bulletin 10-04, we had the guidance that said special areas limited to ground cover. For signalized and unsignalized intersections, the median area along left turn lanes, including the taper, shall be limited to ground cover and height not greater than 18 inches below the sight line datum, regardless of whether or not the area is within the limit of clear sight. This is an example of before the Roadway Design Bulletin came out. This is Thomasville Road in Tallahassee, looking northward, just south of Interstate 10. And you'll notice that the trees do not exist within the median adjacent to the long left turn lane of the I-10 westbound ramp to Pensacola. So after the Roadway Design Bulletin, what changed? We went ahead and looked at the criteria, and we were able to establish that after the release of the bulletin, we changed the parameters so that we had a 100-foot buffer for less than 50 miles an hour design speed and a 200-foot buffer for greater than or equal to 50 mile an hour design speeds for left turn facilities. And this applies to special areas limited to ground cover. So after Roadway Design Bulletin, this is the result of a project that was incorporated at that site. As you can see here, there's plenty of low cover aesthetics, and then as well as trees planted within the median. And it changes the aesthetic view, but it still hasn't changed the function of the actual left turn lane. Based on graphical analysis and physics, we began to consider the questions, how conservative is the tree setback distance? We also said, well, should the setback be the same for signalized and non-signalized intersections? And then in looking to get answers to those questions, the need to research landscaping, highway medians, and intersections became evident. The main objective of the research was to review the current landscaping criteria and also to provide a computational procedure for analyzing different configurations and also to perform an empirical study on the safety performance of Standard Index 546. In looking at the policy in other states, we went back to AASHTO's landscaping policy for intersection, which has two main parts. A, drivers require an unobstructed view of the intersection, and then B, it does not strictly forbid landscaping near intersection approaches. Based on the second part of AASHTO's policy, many states have different criteria to determine the significance of visibility obstructions within intersection approaches. If you note here, California uses, at 25 miles an hour, they use a 150-foot setback. For 30 miles an hour, a 200-foot setback. And then at 35 mile an hour, a 250-foot setback. Where in Louisiana, for 30 mile an hour, it's 300 feet, which is double the 150 for 25. And then for 40, it's 400, 50, it's 500. And then 55 mile an hour, it's 550 feet. The landscaping policy in Florida was developed, we developed more details for tables, and some of the states, like this one for Florida, include the ground cover criterion tables. Under ground cover, the top of the ground cover to the sight line datum, ground cover can only be at greater than 18 inches for ground cover in combination with trees and palms, greater than 24 inches for trees and palms, less than 11 inches in diameter. Then greater than 18 inches for sable palms, greater than 11 inches, but less than 18-inch diameters. Setback restrictions at that time were 100 foot from the pavement edge for design speeds less than 50, and then 200 feet from the pavement edge for design speeds greater than or equal to 50. The trunk plants, the diameter had to be less than or equal to 4 inches, greater than or equal to 5 feet above the sign light datum, and that minimum spacing was at 20 feet. And as you can see, we have the table down at the bottom related to the design speeds, and then the old criteria was for 30 mile an hour with trunks between 4 inches and 11. The spacing was 22 feet, then 27 for 35, and so on. As the diameter gets larger, the spacing gets larger. So for 30 mile an hour, it's 91 feet. For 45, it's 146, and 50, it's 165. So what did we need to do? We needed to review the objectives and our methodology. We looked at the sight distance in Index 546. And we determined that for the sight distance, the driver of a vehicle approaching or departing an intersection should have an unobstructed view of the intersection. This includes any traffic control devices, light poles, overhead sign supports, signal poles, landscaping, and must have sufficient length to anticipate and avoid potential collisions. The unobstructed views form a triangular area that's known as sight triangles. The sight triangle should be clear of obstruction so that it won't block a driver's view of vehicles and/or pedestrians. The other thing that we looked at is departure sight triangles. And on the departure sight triangle, it's important to note that the vision has to be clear for those departing as well. So under sight distance in Index 546, we looked at the approach sight triangles. You can see on the right-hand side, that's the car approaching from right to left. And then on the left-hand side, the vehicle is approaching from left to right. And this is on the major main line. These triangular areas should be large enough so that drivers can see approaching vehicles and pedestrians and have sufficient time to slow or stop, thereby avoiding a crash. The departure sight triangles, you'll notice here, this is the decision point, and there's a departure sight triangle on the major line, and then the decision point on the side street of the minor street. A detailed approach to Development Index 546 was intended to clearly specify the department's interpretation of the AASHTO Green Book. The information shown in Index 546 is intended solely for the purpose of clear sight development and maintenance at intersecting highways, roads, and streets. The index controls spacing between trees, size of trunk diameter, the height of ground cover, and the height of the bottom of the tree canopy within a defined clear sight window. The next thing that we looked at was we studied intersections divided into 3 groups for controlled intersections. This was whether it was signalized or stop sign control on the minor road. No median trees near the intersection. We looked at median trees near the intersection, which were compliant with Index 546. And then we looked at median trees near the intersections, however, non-compliant with Index 546. These are some of the data that came up through the validation of Index 546 based on the computational values. The site distances tables were updated, and what you see here is we have rounded the distances based on feedback from construction. It was hard for them to get out there and actually lay these trees out based on a multiple of a foot increment. So we went and made sure that when we incorporated our new numbers into the design standards, they would be in multiples of 5-foot increments. So what was the next thing we had to look at? We looked at the visibility criteria. We had to look at the restricted visibility, and based on restricted visibility, we had to ensure that 50% of the area is visible, and you have to be able to see the stopped vehicle profile. The next visibility was the unrestricted visibility criteria, and here we looked at the pictorial window and the availability of the line of sight. And here we also applied the 2-second minimum view sight and a minimum tree spacing criteria. So here we're going to look at the perception diagram. This is setting the sable palm. This is our state tree and the spacing criteria. As you can see, the restricted area to the left and then the unrestricted area with the 2-second minimum time gap. It's also, you need to note that additional visibility based on the Florida Highway Landscape Guide suggests that landscaping within the limits of the clear site should not block more than 50% of a driver's view of a passenger car stopped on the minor approach and or pedestrian traffic. It is recommended that the driver on the major road should have a clear view of at least 66% of the passenger car stopped at the approach, and that's what this 2-second gap will provide. The next thing that we looked at was the validation of FDOT Standard Index 546 based on computational values, and then we looked at the tree spacing table. And based on the tree spacing table, we upgraded our numbers. And now for a design speed of 30 miles an hour, when we're looking at trees that are greater than 4 inches but less than 11 inches, it's the design speed -5. So for those plantings, it would be 25, 30, 35, and 40 for low-speed facilities. And then for all other sizes between 11 and 18 inches, it's actually 3 times the design speed is what it comes out to be. So for 30, it's 90. For 35, it's 105. For 40, it's 120. And for 45 miles an hour, it's 135. And then when you look at the high-speed facilities, which are 50 mile an hour and greater, the smaller diameter trunk size is now equal to the speed of the facility. So it's 50 for 50, 55 for 55, and 60 for 60. But then again, if it's between 11 inches and 18 inches, it's 150, 165, and 180. The next thing that was incorporated into the actual research project, a visibility simulator tool was generated. And it was a computational tool, and it evaluated the visibility, and it's enhanced and created more flexibility in the design of landscaping configurations. You can change the intersection plan views. You can change tree spacing and tree configurations. You can input different design speeds, and you can define different vehicle paths. The simulation itself measures the performance, and it generates an output file. So let's take a look at an example of this program. For this intersection, we're looking at the through movement based on the observer, and this is based on a design speed of 40 miles an hour. So we go back into the base scenario in the visibility simulator, and as you can see, on the right-hand side is the starting point, and then the ending point is where the vehicle must stop. And then the visibility simulator will tell you where the tree plantings, where they're at, and then based on that input, they'll be able to create an output file that's going to tell you how the design itself actually performed. So we ran this base scenario in the visibility simulator with this configuration, and then the simulation results for the baseline scenario are shown in this table. The time that it took was 8.7 seconds. The distance that it traversed was 510.4 feet, and the visibility criteria was at 100%. So for the average visibility through that corridor with those tree plantings, we were able to generate a 96.51% average visibility. The unobstructed visibility time was 7.3 seconds with a maximum unobstructed visibility time of 3.7 seconds. Before we applied the threshold distance, it was about 95.81% with an unobstructed visibility time of 3.5, and then of course the maximum unobstructed visibility time of 2 seconds. So on the unobstructed visibility time, the design actually doubled the amount of unobstructed visibility. So for the visibility profile, the software generates a graph, and you can look at the graph. You have visibility on the left-hand side in percentages. At the top, it's the time gap, and when we look at the 2-second time gap, we can see that the model works very well, and then the distance within that time gap. So the distance starts from 0 and then traverses to the 510 feet from before. It can be observed that by following the tree spacing specifications established in Index 546, the 2-second unobstructed visibility window is achieved. So that's what we're looking at in the top graph. The tool may be useful to test variable tree and intersection configurations, determine if they are compliant with Index 546. Currently, our engineering CAD support office, in cooperation with our landscaping office and also the design office, is looking at taking this tool and actually creating a tool that will work within our CAD software and potentially make it work so that it works in the 3D environment. So we're looking to actually enhance this tool, take it to another level, and that should be something that everyone can look forward to within the near future. So let's take a look at some of the conclusions and recommendations. The research was completed in September of 2013, and the validation of Index 546. The tree spacing table is on sheet 1 of 6, and then site distance tables are included for sheets 2 through 6. The recommended setback for the medians from the median nose is 120 feet for design speeds less than 50 miles an hour, and then 200 feet for design speeds greater than or equal to 50 miles an hour. The design standard Index 546 site distance at intersections. We looked at landscaping highway medians at intersections through our research. We discussed the need for the research. We reviewed the validation of the current criteria. We also looked at the recommended changes. We discussed the research objectives and methodology, and then of course reviewed current landscaping criteria, provided a computational procedure to analyze landscaping configurations, and then also performed an empirical study on the safety performance of Index 546. Additional conclusions and recommendations. The Visibility Tool Simulator, it handles the flexibility and design of landscape configurations. Again, like I said, it may be available in the future for design of medians with trees. The tables have been revised in Design Standard Index 546. And the tree spacing, site distance, setbacks have been updated for medians, and these are currently at 120 feet for design speeds less than 50 miles an hour and 200 feet for design speeds greater than or equal to 50 miles an hour. However, I do want to note this 120 feet for design speeds less than 50 miles an hour. This setback distance is still in discussion, and it may increase to 150 feet pending the final resolve of those discussions. We had a few questions, and one of the things that kind of stood out to me was the question on landscaping at roundabouts. I took this picture yesterday while I was on my way to Starbucks and said, "Oh, this will be great. This fits perfectly into the webinar." And as you can see, even within the island in between where the silver car is, you can see the pedestrian sign. There's actually trees in that component as well as within the actual circular component of the roundabout. The facilities that run through here are the approach that I'm taking this photo from is a 30-mile-an-hour facility, and the crossroad coming into this roundabout is a 35-mile-an-hour facility. The only issue that I have, and really isn't relevant to this presentation, is on the right-hand side where you see the yield sign and then the pedestrian crossing sign. There's actually a bus stop there, and then usually around noon the bus will come there and stop, and it impedes the traffic as it's supposed to flow into the roundabout. In order to address the question, I just wanted to ensure that that people who have questions about plantings and roundabouts. There's a Federal Highway publication. It's FHWA-RD-00-067, and that's titled Roundabouts, an Informational Guide. If you go to Chapter 6 on Geometric Design, it covers the stopping site distance and site distances within roundabouts. You can find some detailed exhibits and discussion on page 6-62 and 6-63, and this covers the intersection site distance within the roundabout. Another issue that I want to kind of look at is tree maintenance concerns. We had a lot of questions on maintaining the plantings once they're within the median and on the shoulders. Tree maintenance is an ongoing concern for all agencies. Clearly, the clear sight window is a crucial aspect of median tree landscaping, which must be maintained in order to ensure the safety of motorists and pedestrians alike. This picture was taken yesterday. It's a 35-mile-an-hour facility. I don't know if everybody can see it, but there is there's actually a city bus that is stopped on the other side of the road, And the only way you can see that in this photo is if you look closely, you can see the two headlights that kind of shine through the trees somewhere to the left of the center of the photo. The bus stopped and let a pedestrian out. The pedestrian was getting ready to cross the road. As I approached that part of the roadway, I had to slow down to make sure that the pedestrian had adequate time to get across. So again, tree maintenance, planting the trees out there and ensuring that you have that clear sight window is a very, very, very crucial item. The next thing I'd like to discuss just briefly is Index 546 and compliance. This is another location I frequent quite well. It's close to the place where I eat lunch. And here, tree spacing, tree setback, and then the tree type and diameter are very critical. The tree spacing, the spacing of the crepe myrtles within the median behind the signal actually adversely impact the creation of the two rows of the plantings. So if you look in the median, you'll see the left turn arrow. The crepe myrtles that are on the other side actually engulf the overhead signal sign support. So in this case, setback was not achieved, and then by planting two rows, while the trees were on the other side were spaced correctly, they were offset so that if a vehicle actually had to go and try to traverse through the median, it actually reduces the spacings by 50% and provides less of a corridor for anybody to be able to get through. The tree type and diameter, the crepe myrtle plantings have multiple smaller trunks, as you can see on the left-hand side where the left turn movement is. The departments, state and district landscape architects met recently, and they've decided to remove the crepe myrtle as an eligible landscape planting on state road facilities. I did not get into the discussion on exactly what it was about, but I would imagine it does deal with the planting itself and some of the complications that it provides. Just a quick roadside factoid. I'm on the roadside safety side, much like Dick Albin is, and nationally trees that are located within the right-of-way are the largest contributor to highway fatalities within the nation. Dick did show some crash testing, and he said it was in kilometers. I was not aware that we actually had any crash tests, but I know that MASH and NCHRP 350 don't have any crash test criteria that would allow you to go through and crash test trees. I guess as a follow-up note, my main concern is plant trees responsibly and then plant them where they make sense and according to established criteria. I guess at this point my presentation is complete, and I can go ahead and turn it back over to Dan.
Okay. Thanks very much to both of our presenters. We have some time now just for a couple of questions. I know we're right at the end of the session. I do want to ask two questions that kept coming up repeatedly, and then I want to share just briefly some resources with you that you might find to be helpful as sort of future reading. So let me just hit these couple of questions, and then what we'll try to do is maybe post responses to some of these other questions that are very good questions that we got maybe to the website after the session is completed. Dick and John, one of the questions that kept coming up was in reference to overhead clearance and tree branches that extend over the roadway. A lot of the research that you shared, a lot of the issues were on the roadway departure side. Any quick references or guidance you can provide on that vertical clearance or how tree branches can impact traffic along the roadway in that way?
I don't have a great answer for, just, if AASHTO has anything like that. I would suspect that you'd want it to be, not in the windshield area, and sight distance would be a part of that as well. I know more on the other side, on the sidewalk side, with the ADA part of it, you need to have at least 7 feet up so people don't run into the branches. But I don't know if there is a criteria for saying that obstacles, there's the vertical clearance if you're going under a bridge, you need to have big trucks go under, but a branch, whether that would just be brushed out of the way, I don't know. So I don't have a a real good answer on that one for you.
Okay. Oh, that's
Yeah. In index 546 on sheet 2 of 6, I showed the picture of the tree in the median and kind of discussed the restricted and unrestricted views. But that pictorial is the window detail that gives you the window of view that you have to maintain. So the bottom of the canopy is 5 feet above the sight line, and then the top of the ground cover has to be 1.5 feet below that line of sight. And the line of sight is established at 3.5 feet above the profile line at the edge of travel.
okay.
We do provide guidance for medians. I would anticipate that that would probably apply to the shoulder as well. But again, it's really, like I showed in the pictures, it's a maintenance concern. You have to make sure that maintenance is out there and they're maintaining that sight line window.
Okay. Very good. And the second question that came up quite a bit, you did mention a lot of research referencing different crashes and different design speeds and posted speeds. There were some questions about whether there's similar data or similar research available for the actual speeds that the vehicles were traveling at the time of impact, and whether those were different from the posted speeds, maybe if they were higher. Can you speak to any of that data that you've seen or anything that might be available?
Yeah, the information that we have, the best information we have comes from FARS, with Fatal Analysis Reporting System, and they don't go out and reconstruct and try to assess what the speed was at the impact or anything like that. So we really don't have that. Different studies have been done that have looked at a sample of crashes that where vehicles ran off the road, and looked at what the speeds were when they ran into them and things like that. And that's actually how our crash test criteria was confirmed. But right now, I couldn't tell you that. I do know that on some of the routes that I showed you that had posted speeds of, say, 45, the 85th percentile speeds were sometimes a little bit more than that. I think in one case it went from 48 to 44 in the after condition. So, the 85th percentile was that, but I don't know for what the actual driver that ran into the tree was done. Generally, those don't get reconstructed or determined for every crash.
Okay. Thanks, Dick. John, anything to add to that one? Oh, if not, that's quite all right. We are, unfortunately, we are out of time for questions. As I mentioned, though, what I'd like to do is maybe compile some responses to a lot of these questions and add them to the archive page. So you'll be able to see those if you come back to the website and look at the, when you check that link in your email later today, you'll hopefully be able to find that information there. I wanted to mention just really quickly 3 resources that to leave you with and maybe provide you a little bit more information and guidance moving forward on some of the issues that were discussed. Really quickly, this guide for maintaining pedestrian facilities was produced by FHWA last year. If you look in Chapter 6, Section 6.6 specifically, you can find information about street trees and a lot more detail in terms of planting street trees when you're looking at soil selection and volume, which can get at things like compaction and sidewalk maintenance issues and things like that. So that is one resource you'll find available. Another one is called the Model Design Manual for Living Streets, produced for LA County, but this is a great design resource for in all areas, but specifically Chapter 11 talks about the streetscape ecosystem and just addresses issues such as planting sites for street trees, climate and soil, selecting different types of species for different types of settings, and spacing and lighting and things like that, which is also available to you online. The third resource I just want to leave you with here is a great guide for developing a street tree master plan. This is a really good resource for individuals in cities, a lot of different types of professionals, planners, engineers, elected officials, kind of working through the process of where street trees belong and where they should be placed, how they can be located in safe areas, and a lot more information about planting sites and things like that. So again, these are some resources. Hopefully will help answer some of the other questions that you have. These will be included with the slides that we post to the website at the end of the day. So you'll have access to these links and can follow up for more information as well. We want to thank you all again for spending some time with us today to learn about this issue. And I want to say a special thank you to our presenters and panelists for providing these presentations to us today. We will be posting a recording of today's program in about a week at pedbikeinfo.org/webinars. And again, the specific link will be in your email that you receive later today. And each of you will receive that follow-up email this afternoon, and it'll have the link to the slides and a place where you can find some more information that we shared today. I want to remind you all that a very brief survey should appear once the webinar is over. If you can take some time to provide some feedback to us, we would appreciate it very much. It'll help us to guide presentations that we offer in the future. Again, thank you to our speakers, and thanks to all of you for attending today's Pedestrian Focus webinar. And have a great day.